something I came across and I have not yet been able to prove. So the thing is, there is an isosceles triangle where the sides are 1. What should be the length the length of the third side to maximize the area? So the puzzle also said do this without using calculus. So anyway, we will not venture into calculus.
Is it? That's what it says.
Yeah.
Calculus.
I saw, what is the spelling? Isosceles triangle with the two equal sides of length 1. What should be length of third side to maximize area of the triangle?
Yeah. Okay, so can we all take some time to work independently and we'll come back to this?
Yeah. So one case is when, one extreme case is when both the lines are so close together they barely form a triangle. This is one case. The other extreme case is the two lines are pressed down so much that I have an answer, but I can't justify it very well.
The third side should be very little less than 2. Because if it becomes 2, it will become a straight line. The triangle will become a straight line.
Huh.
So the
so like this, this you're saying.
Yes, the height should be the very minimal height, whatever minimal height possible.
Okay. So like, so then it would be, let's say this is 1.9. Instead of 2, this is 1.9. Is the base.
Yes.
Then height would be, so this is 1. This is also 1. So height would be 1 squared minus what is half of 1.9? 0.95 squared. Okay, calculator. 1 minus 0.95 squared. 0.095. We need square root of that. Point 0.31. That is 0.31. So area would be 1.9 into 0.31 by 2. Point 2945. So in this other extreme case, if we just put it up a little bit, so that let's say this is just 0.1. The bottom is just 0.1. Then what happens? 0.99. Height is 0.99.
Yeah, not fully, yeah, not solve it, but yes, we can discuss.
Point 1 star 0.99 by 2. 0.0495. Oh. Did I do it properly? So 1 minus, oh, sorry, this should be 0.05 squared. Okay, 0.998. Doesn't matter. I've taken it as 0.99. So then 0.1 star 0.99 by 2. 0.0495.
ಸ್ಮಾಲೆಸ್ಟ್ ಏರಿಯಾ ಆದ್ರೆ ಹಿಂಗ್ ಹೇಳ್ಬೋದು, ಲಾರ್ಜ್ ಏರಿಯಾ ಅಂದ್ರೆ ಹಂಗಲ್ಲ. ಮ್ಯಾಕ್ಸಿಮೈಸ್ ನಾನು ಮಿನಿಮೈಸ್ ಮಾಡ್ಬಿಟ್ಟಿದೀನಿ.
No, this is of the two values that we have, this is the smaller one, this is the larger one, and this is the one that you proposed. So of the two values that we have, this is definitely the larger. But is this the largest possible? We still don't know.
So I am making use of a formula for the area of triangle, and I use that to find out what the side will be and what the maximum area will be.
Oh, Heron's formula.
Not cross formula, a different, simpler, but yeah, more useful formula.
Okay. Hari, you were saying something?
Oh no. I did not use it. I can't justify anything. I am still there. I can't. So what I did was I was just looking at rectangles with one as the diameter.
Exactly. I was doing the same thing.
Yeah.
Quadrilaterals. Quadrilaterals with sides as 1.
Oh, side as 1, but I was. That is a different approach, I think, right?
Oh,
This
okay.
is rectangles with diagonal 1.
Oh, rectangles with diagonal 1.
Uh,
Acha, acha. Okay, wait 1 second. Let me draw it. Rectangle. And we have the diagonal. Oops.
But how?
And this is 1.
I don't know how to show the square will have the max area.
So what I did was, I said consider any quadrilateral with all sides being 1. The maximum area, okay, I'm using something I know. I'm told that for a given perimeter, the maximum area comes from a square.
Oh.
So using that, I'm claiming, okay, this has to be a right angle. Then only we'll get maximum area.
Okay.
Okay, so Gauri, we can like give a proper proof also. Like what you said is correct, but you don't have to like make a logical leap. So here all four sides are going to be 1, so it will be a rhombus.
Yes.
And area of the rhombus is going to be base into height.
Correct.
So your height will be
yes.
maximum inch square.
Yes.
Wait. Area of the rhombus is base into height. Okay. And then?
So the height will be maximum when it is a square.
Right. Oh, right. Nice.
So Hari, your approach is also like very interesting. I mean, I didn't think of this, and this will also lead to the same answer, I feel. So what you have is, you have a square plus b square equal to 1. You are trying to maximize ab.
Yeah.
This is basically how we are looking at it, right?
Yeah.
So basically, what Hari, I mean, by Hari's approach, the area of the rectangle is going to be the area of the triangle.
Correct.
Right.
So it is now a question of finding the maximum area of the rectangle.
Yes.
With the diagonal as 1, yeah.
Yes.
This is beautiful interpretation, no? Okay. So this question is same as asking like a diagonal of a rectangle is 1.
Hmm.
Now find the maximum, like which rectangle has the maximum area.
Hmm.
Oh.
So I probably have like the lamest proof. So area of the triangle will be half AB into sine C.
Hmm.
So A and B are the sides and C is the angle between.
Fine. Yes, this is some sign rule or something like that.
So here A and B is 1. So area is going to be sine C by 2.
Yeah.
And sin C will be maximum at 90. Oh.
Yeah.
And proving that area is equal to half product of the sides into sine C, that is not very difficult. I mean, it is like it will just take.
Yeah. Yeah.
Okay. I have not solved it, but I have like a interpretation to it. So what I did was I took a circle of radius 1. Okay. Now basically I'll draw any 2 radii to make a sector. So now the question that is asked is if I join the 2 points, okay, that is the triangle that we are talking about. So which of these triangles have the maximum area? Right. So yeah, so the other interesting thing is I was trying to look at the other piece of the circle, which is not the part of the triangle, and trying to see in order to maximize the area that so basically that thing should be less. Yeah.
No. Oh.
Maximizing angle, if it is more also it will be less. So.
No,
It is going.
you are trying to maximize or minimize the area of the segment.
Minimize the area of the segment to maximize the area of the triangle.
Yes.
But here, when you increase the angle, even though the segment that is being cut off is bigger.
Yeah, the area itself
is bigger, yeah.
itself
is
bigger, yeah. I was actually playing around with isosceles triangles a little bit. So what I did was I cut the isosceles triangle in between.
Okay.
So it drew a perpendicular. So interestingly, for isosceles triangle, the perpendicular also happens to be a bisector. So both perpendiculars are same.
Yeah.
So now we get like 2 congruent right-angled triangles.
Yes.
So what I did was I took 2 more of those same pieces and I arranged it in a how do I say it? If you take the orange piece, no, that's like that is like a part of the isosceles triangle.
Yes.
So here, interestingly, for every isosceles triangle that I can do this. So one other way I was thinking of is, but the in between, like the hollow thing, can be more for some and then can be less for something else. So basically for every right angle triangle, I can do this. So I was thinking like for which of the things the hollow square that I get or the hollow thing that I get is minimum. So
here,
that means the pieces will be maximum.
right.
Wow, super.
So this will be one.
Square is
That will be one anyway, right? No matter what I do.
This will be height. This will be half. Oh, so the inside square is actually fixed to be one square.
Yeah, the inside square is always one. It's the other thing will get bigger, is it? The thing itself will get bigger. So because that one can't change.
One can't change.
Yeah.
Yes.
So this is not half though. This is not half, right?
yeah, that will be half of the third side.
Half of the third side. Yeah, half C.
Which is what? Half of C. What is C? Oh, I
Sorry, C is the third side.
can't.
If we call it C, okay, I will just erase that. Okay, this is what we know. So for what length of this third side will this outer square be maximum? Okay, it is it is this plus this and this both come into the picture. Height and base by 2.
This, but wait. No. So there is this is one formulation.
Wait. So we have to maximize height plus base if we maximize.
Height plus, yeah, it's a similar thing. Yeah.
This is base by 2. So if we maximize height plus base, we will have the biggest possible outer square.
Yes.
So when you say maximize height plus base, it can't be any random big value. It is constrained by something. Which is
so we
the
have
square
the
plus the square is one.
base square plus height square should be 1.
1 by 4 base squared plus height squared is 1. So this is how you do it with calculus. I don't know. Starting with this equation. Yeah, but it's hard to think about, no? Like maximize height plus base given this constraint that 1 by 4 base square plus h squared is.
Yeah, basically we need to draw a curve, like what kind of a curve is this, and then what value. Oh yeah, that becomes tough. So one more thing is we can also draw these 4 triangles in a slightly different way. In the same image, you will see like 2 ways in which it is arranged.
Oh, okay.
Wow, what an idea. So, oh my God.
No. The side won't be 1. Side is no h.
No.
No,
Side
side
is
will
always
be
1.
1. So we started with.
Oh yeah, correct. Sorry, yeah. Correct.
Wow, how can this be arranged like this?
So I wanted to do something else. I wanted to find the area of the isosceles triangle without using Pythagoras theorem. That was the exploration I was doing. So the idea was I wanted to fit in the isosceles triangle. So my basic idea was how many isosceles triangles I can fit into a square, and then use the fraction thing.
Oh, okay.
And then I was playing around.
So here the size of this is height minus
Minus.
base by 2. So we have to make this small. Okay, right.
So height minus base by 2 should be as small as possible.
Right.
And they should be same then.
And they should be?
No, in the sense,
Oh.
essentially they should be same.
Oh, there we have it.
As small as possible means we can base.
Height minus base by 2 should be as small as possible. The smallest it can be is 0, which means height must be equal to base by 2.
Wow, what an idea. Oh my god. What poetry is this?
Wait, does that give us the same answer? Height must be equal to base
Yeah,
by 2.
Yes.
yes. It will.
I don't see it. Wait.
No, if you look at the answer that we got,
Huh.
so it's an isosceles triangle where the angle between is 90.
Yes,
So the base
the
is root 2.
correct.
Now if you draw an altitude, you can find the altitude.
Hmm. 1 minute. Oh, okay.
I'm surprised. I did not see it going anywhere.
Yeah.
Okay,
suddenly-
so now I can see the intuition over here. So here we are taking twice the area of the triangle, right?
Yes.
So it is like the colored part is like twice the area of the triangles, and there's a hole in between, and
Yes.
the side of the square is always 1.
Yes.
So the area of the triangle is going to be 1 minus the area of the hole in between.
By 2.
Correct, by 2.
Hmm.
So we want to maximize the area of the triangle.
Yes.
So that will happen when that hole is like 0.
Non-existent.
Yes.
Wow, 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 wow. Yeah. So that will only happen when okay. Very nice. Beautiful.
Oh, interesting.
There is one more observation. Can we use Heron's formula here?
I have no clue what, I mean, I've heard of it, but I
No,
don't
no, yeah,
remember
we
what.
can use.
So you
Like
can
when
tell.
we have three sides,
Huh.
when we
Smita,
have
you
three,
go ahead.
assuming I just tried to assume the third side to be 2, and the
Okay.
area turned out to be 0.
Okay.
So
Yeah.
anything above 2 cannot be possible. It won't be possible to get the area. It comes in some
Right.
negative.
Right.
So anything below 2 should be giving us the greatest area. That in the sense, it should be probably 1.99, even if that is the number that would be giving the highest of area.
Right.
Okay, so the formula is square area is equal to square root of s into square root of s into s minus a into s minus b into s minus c. Where a, b, c are the sides.
Is this correct?
Yeah, right. By a plus b plus c by 2.
Oh, I see. Okay. So now if we have, so in our isosceles triangle, we have 1 and 1. If this happens to, if we make this 2, area is 0. Right. That will 4 by 2.
Gonna be
2. Yes.
0.
Yes. So that comes out So we know A and B is 1. So S will be 1 plus C by 2. So area will be square root of.
It will be 2 plus C by 2 because A and B both are 1. So A plus B. Oh, right. Okay, sorry.
I removed that from the fraction.
Yes, yes.
So S into S minus A, S minus B is fine. When it comes to S minus C will be 1 minus C by 2. Correct?
And that's going to be 0.
If C is 2, right? But
Oh,
for
so
maximizing the area, how do we take this further?
So anything above 2, I'm getting it as negative. So it can be only between 1 and 2.
yes.
Correct.
So, and the maximum area would be 1.99. It can be recurring until you don't touch 2, it's fine.
Correct.
No, but then how are we? So okay, for 2 we'll get an area 0. For 1, and so yeah, base has to be less than 2. That is very clear.
So it depends. Now, if I'm taking the degrees only in terms of 179 would be the apex angle, then it could be something like that. If at all I'm taking even those angles in points, then here also we can just go on taking the recurring value of 1.9.
Wait. I think you are maximizing the length. Am I correct?
And that
Ah.
could happen only when I go on maximizing the apex angle.
Oh, but no. So the question is slightly different. So we have to maximize the area.
That happens only when this length gets maximized. Right?
Oh, is it? But the height will also reduce, right? As we
Right.
So area is half into B into H. If we try to maximize B, H will go down. If we try to maximize H, B will go down. So how do we find the sweet spot which will make this the maximum?
So then it should be a midpoint value.
Midpoint.
I kind of like that argument. So
Sorry?
why hello?
Yes, go ahead.
So Sri Latan, you mentioned it should be the midpoint. So I really like that intuition. Can we find like a proof for this? Like in
I
terms of
remember
just,
something we had done recently when Shivu had asked one question where some pebbles will be there. If you go on multiplying them in the elementary, this one, you will get that midpoint numbers. When you multiply, you get the maximum.
Yes, it is exactly the same. I was also just recalling that and seeing the similarity.
Here, we can just like write the Heron's formula and see what expression we get. So we have seen now when you put C equal to 2, it gives 0. But we will just write the general expression for area using Heron's formula only.
Yeah, so I got something like C by 2 root of this is 1 minus C by 2 into 1 plus C by, so 1 minus A into 1 plus A. So this is 1 A square.
yes. After Heron's formula, I just want to say something. Okay, just remind me.
This is correct.
Okay.
So
Can you?
yeah. So in Heron's formula, we have put the value of S as 1 plus C by 2. S minus A will be C by 2. S minus B will be C by 2. S minus C will be 1 minus C by 2. So we get C squared by 4. So that C by 2 will come out. C by 2 into square root of 1 plus c by 2 into 1 minus c by 2. That is 1 square root of 1 squared minus, I don't know if it helps to do that, 1 squared minus c squared by 4.
Yes.
Oh, this leads us to this.
Oh, then that is nothing but wait.
That leads us back to this only, right? This 1 squared minus c squared by 4, isn't that
same as
this 1 squared c by 2 whole squared? Yeah. So the area of this outer square is 1. And the area of this inner square is, where c is the base, so it is c by 2 whole squared, so c squared by 4. So isn't this exactly that?
yeah, 1 minus.
Yeah. I want to like this see. So you have the square hole, right? How do you know
Yeah.
what is the side of that square hole?
I'm saying it only in terms of the base. So it is base by 2. Oh, sorry. Not base by 2 whole square. It is
It must be h minus c by
h
2.
minus, yeah, correct. Yeah, you're right. Okay, yeah, sorry, my bad. Okay, where do we go from here in this?
So now we need to we need to find for what value this will give the maximum number. I guess that will like take us to calculus.
Okay. So one thing I wanted to ask is, so going back by Sri Lanka ma'am's intuition of it should be midpoint, can we use some symmetry argument here?
Yes.
I don't know. I'm feeling this is a question Paul Lockhart would put, and he likes symmetry.
So another interesting thing that I found about this is, any triangle I can break it into 2 right angle triangles, and I was trying to see any triangle, like I can make these patterns of
So you can
making,
make that rectangle, right?
yes. So
And
it will
if it is an isosceles, we'll make a square.
be a rectangle.
Nice. Wow. So inside also, will it be a similar rectangle?
So if you start with a random triangle, a scaling triangle, you are splitting it into 2 right angle triangles.
Yes.
Yeah.
And effectively, you are looking at the rectangle that encloses this. So you will have like 2 pairs of right angle triangles.
Rectangle enclosing this.
No, not okay. Yeah, this is.
So you basically have 4 pieces. Now
Yes.
you can rearrange these 4 pieces again, but now it won't be the square, it will be like a rectangle, right?
Yes.
So
And
you
would
have
the
rectangle, but the whole will be a rectangle or will it be a parallelogram?
whole will be
That
if
we
it is peeling, it's a rectangle.
Yeah, that we need to
Oh, I
see.
don't know. I'm not sure. No, I'm not sure.
Here, can we also say that base is inversely proportional to height?
Can we say base is inversely proportional, right?
Yes, correct.
And
No, it is not inversely proportional. We can say that when base increases, the height will reduce, but it
it's
is
not
not the
inversely
same as
proportional.
proportional.
Okay.
Uh,
Now I was wondering if it is inversely proportional, then any value should be okay, same, right? Like
Exactly, yes.
right.
So I was trying to explore this for this very reason that if it is inversely proportional, then every isosceles, like every triangle, which is like part of the circle, like every isosceles triangle will give the same area.
So yeah, this will be like a good example of two quantities where when one increases, the other decreases, but they are not inversely proportional.
Right.
Super, super. I did not get the idea that they'll be same area. How are you saying it?
So
Oh,
basically,
taken to height. Okay.
taking the product. So if something
Yes,
multiplied by a quantity, that the other will reduce by that same quantity, or like
fine,
divide
fine,
by
fine. Yeah, they should remain the same. Okay, understood.
product. Should be.
Should be same. Yes. Nice.
So
So Nagesh, you mentioned this will work for any scalene triangle, and if you put any scalene triangle, you cut these things and put it together, it will form a rectangle. There is a rectangle or like some quadrilateral will be formed like
this
this.
is an
So
illusion,
Ashwin,
not tried it. Like I've not.
intuition. Oh, fine, fine. Can we try it out? And I'm also interested in whether the inside rectangle and the outside rectangle, if they are rectangles, whether they'll be similar.
Okay. What will happen if we can try that out.
And also one more thing, what I was thinking of is can we form some symmetry arguments for this? Is it possible to think of something like that?
Yeah. Now I'm trying to rearrange it, but it is not like I don't remember how I did it in the first.
So the 90, the other two angles should mix together.
And that should be the.
Wait, no. That
This is the starting point, right? This is the starting point.
Yes.
Okay, fine. Now
Now,
the small triangle.
I'm just going to rotate all of them clockwise by some amount. And
No,
see
this
what
is not the way. This is getting the
parallelogram.
no. Just put that. Okay, rotate it more. Can you fit that onto the other?
So
We need the outer things to be right
The
angles,
sides
right?
of no. Outer things.
The outer angles should be right angles.
it will turn out you have to keep the big small alternate.
Big small alternate.
Correct. Hari, you're doing this in your mind.
I don't have any other tools as of now. Oh, this is the other one. That is also
So
okay.
this is the first big hole that we made.
Huh.
Right. Now with the same pieces, I think we can get a rectangular hole also.
Yes.
So what we did there was the hypotenuse should be to the outside.
Exactly. Hypotenuse towards the outside. Or maybe you can save this and then do another one. Can you undo and copy and drag, and then you can make one. Not this way.
How will I get right angles if the hypotenuse is to the outside?
I don't think it will be like a.
Oh, so this and this will add up to give a right angle. This and this
Oh,
will
here I can't alternate.
we can't
Here I
alternate.
can't. Interesting, no?
So if this is this is here, then I need to put.
Oh, then it won't
Okay.
match, no?
No, here also I think it will be like big, small will alternate.
But big, small, we
Then I
won't.
won't get right angles, no?
Yeah, we won't get right angle.
Wait, how do we arrange this?
This is a right angle, but we can't close this gap now. I see your point. But now, can we try to make a parallelogram then? I think that angle should add up. Yeah, this will close. This will be 90, but we can't close the.
What if we flip it? Will that help?
Sorry?
Flip it.
Flip it. Oh, okay. Flip. I think better to do it with some paper.
Yeah, I'm trying with paper.
So I could make a parallelogram with a rectangular hole by putting it in the other way. Oh,
There's no hole.
there's no hole.
Or this happened to be like that. Exception without a hole is.
Okay, there is a hole, but here.
No, you will just get a parallelogram.
Okay, so my thing might be a problem with just me doing with paper. Yeah, it's just I can readjust it and I get a parallelogram. So yeah.
Oh, there is no hole. Oh. I was just looking at the figure and the green, like the arrangement that we have made. Okay, so it suddenly occurred to me that it is like, oh, so take any triangle, make a outside box. Okay, so we get same two triangles the other side, right? Now delete the ones that we made. So, and similarly reflect it and then flip it, and then we get. So interestingly, if I do this, the inside one is always like a parallelogram, and the external one is always a rectangle. Hey, yeah, this could be like, yeah, what fraction of it is like whole, and then what fraction is shaded. Yeah, this also makes like a good fraction problem, I would say. And yeah, always half. It will always be.
What is half?
No, like not. I mean, both are same. So the outside thing it will be same as the inside thing. So the whole is half of like half of the yeah. Say, isn't this what we did below? So the whole did we get the whole?
Yes.
Okay, fine. So we just made a. Okay.
Yeah, I think we can stop here for today.